my fifth lecture of this course. This is I with you with a new context by different dimension style. In today's lecture, I am presenting with you how to define slab properties and shear wall properties in ETABS software. So let's start. Welcome to my lecture again, and this is my fifth lecture for this courses where I actually discuss today how we can define slab properties and shear wall properties. So all the data has already been done or put into ETABS software in my previous lecture. From that portion I want to start. So after that, first of all we have to define section properties, then we have to click slab section. So by default some slab properties has been assigned here. If we want to click slab 1, we have to modify, or if we want to add new properties, so we can continue. So add new properties. So first of all, property name should be the slab property should be the slab is 5 inch. The thickness of slab should be 5 inch. For this reason the property name should be slab 5. So the slab material will be concrete, and this we actually want to discuss modeling type. That is, the slab should be cell thin, thick, membrane or layered. So if I want to discuss with you what is cell, what is membrane. Cell is such type of structure that can take in plane or out of plane stress. So cell is such type of structure that actually withstand or can bear in plane or out of plane, that is perpendicular to the plane stress. So that's why that is cell. For these purposes we have to consider, or we understand that the slab should be cell, but all the load is transferred from slab to beam, floor beam. So slab actually cannot take any stresses. It can actually only stress in plane. Horizontally loads comes into slab because slab is constructed monolithically. So that's why slab should be treated as membrane, because membrane is such type of structure by which only in plane stress has come to the structure. So slab should be treated as membrane. So that's why if we want to color the sense, we have to change it by clicking on this, and the thickness should be 5 inch. So if we click membrane, use a specified on-way load distribution, but our slab should be such that here we can see that all the sides of our slab that is actually surrounded with beam. So load will be distributed by 4 sides, and all sides will be surrounded by support, that is beam, and load will be distributed in 2 ways, that is x direction and that is y direction, and all the sides are surrounded by supported, that is beam. So that's why it is actually 2-way slab. So we doesn't need to click on a load distribution, so we have to then click OK. Again we have to add new properties for STAAD slab. If we consider on this STAAD slab, what will be that should be actually so here is that this is actually our slab. So here it is. By this system we want to construct this STAAD. So first of all we have to rise up onto this, and the landing should be here, and then we have to go through this by upper floor. Okay, so this is actually happened. So the STAAD consists of rise and thread. That is rise and thread. That is it is the thread that should be 10 inch, and this is actually rise that should be 6 inch. So this will be happened, and in ETABS software we cannot construct or build rise and thread that is actually considered as a slab, that is named after STAAD slab or waist slab. STAAD slab or waist slab, and averagely we should consider the thickness of waist slab, that is 8 inch. That is already provided here, I think so. So okay, waist or STAAD slab, that is 8 inch. So for this reason we have to named after, that is slab 8, and slab material that should be concrete, and by this here it is also membrane because it is also slab. So it should be membrane because it only take only in plane stage. Here we can return in grade beam or floor beam layout. So this is actually the STAAD beam. This is also actually the STAAD beam, and this is also STAAD beam. Here is also one landing and another portion is on landing. So the load will be distributed this slab beam and this slab beam. So here we can conclude it here that the load will be distributed in this direction, only one direction, and this portion will the load will not be distributed. So that's why it is actually one-way slab. So we have to click membrane and click use a special one-way load distribution, and the thickness should be 8 inch. So then okay, then slab 5, slab 8 has already been defined here. So finally we have to click OK. So then actually we have to define section properties. In this section is wall section. We have to define shear wall. By default wall 1 has been assigned here, so we have to add new property, that is wall 10, that is shear wall 10. If we return on our plan, that is our here it is brick wall thickness 5 inch and shear wall is 10 inch. Shear wall is 10 inch. So for this reason we have to property name wall 10, that is shear wall 10, and wall material should be concrete. And here the question is, it will be shell or membrane. It does not comply with membrane, it should be shell, because we return back in grade beam layout or floor beam layout. In shear we easily observe that shear wall is actually such type of structure. It can withstand in plane and out of plane stress together and simultaneously. Shear wall is such type of structure, it can easily withstand or bear in plane or out of plane together. So that's why it can be considered as shell. So but our question is shell thin or shell thick, what will be? So shell thin or thick, we have to understand some information about on this. That is, we have to consider one thing, that is T divided by L. T is the thickness of shear wall and L will be the distance of this, and this is actually T is the thickness of the shear wall and L is the thickness of the shear wall, the length or width of the shear wall. So here it is T is equal to 10 inch divided by L is 10 feet. So 10 into 12. So 10 divided by 120, that will be actually 10 divided by 120. So if it is actually, so so if we consider this 10 by 120 is actually, by calculating this, we can conclude that 0.08. So our system is, our clue is T divided by L greater than 1 by 15. So the shell will be thick. T by L greater than 1 by 15, the shell will be thick. So our value is, we have actually got 0.08 and 1 by 50 will be 0.07. So T by L greater than 1 by 15, so the shell will be thick. So the shell thick should be clicked, and here the thickness will be 10. So but when the shell thin will be considered, if the T by L less than 1 by 15, the shell will be thin. So for this reason we have to consider basically shell thin, we have to consider slab, okay, and T by L greater than 1 by 50. For this we consider it footing or rough foundation. So this is actually happened for these conditions, so then it is okay. So okay. So this is actually up to this lecture, because all the information has already been defined for column section, floor beam layout, and grain beam layout, slab section properties, that is slab, waste slab, and shear wall. And finally I have to correct it on things, that is I have already done it, that is in define material properties, and should be selected concrete, and then modified or show materials. And here it is modulus of elasticity. If the FC prime is 3500, the value should be 3372. Okay, then okay. So this is up to my lecture. Thank you very much for your patience, and let's see what is happening to my next lecture.